Ladies and gentlemen, this is episode 10, double digits for the Efficiency Equation podcast. I'm excited to have made it here. And for today's topic, we chose something super exciting, somewhat controversial, and somewhat futuristic in the sense that we're going to be talking about artificial intelligence and its implications. Because even though AI is here living with us and impacting our plants, our factories, there are still not a lot of deep applications into manufacturing execution systems. So some of what we're going to talk about is theory. Some of what we're going to talk about is actual features and stuff that is built in the systems that we build and that we use every day. I'm going to give you a word of warning, ladies and gentlemen, that this topic, the way we look at it and our angle is not going to be like hooray optimistic. Right? AI is huge because the data is telling us otherwise. So although we are super bullish on AI and what it can do to expedite and improve and optimize the way we manufacture liquids, even though we totally believe in that, we're going to look on the not the dark side, but the not so bright side of things and the current limitations. So with that long intro, I want to welcome you guys again. Konstantin and Eugene, welcome to episode 10.
Thank
We
you.
are maturing, certainly. And we've been waiting to do this episode.
Absolutely.
So are you excited to dive in?
Yes.
Very much so.
Okay, so a simple question. We'll start with the easy ones, and then I'll have some curveballs flying at you. But why is AI becoming so crucial in manufacturing right now? Because for the most of us, AI is chatbots. It's turning on GPT, asking it questions. What's it doing currently in manufacturing, and why are you excited about it?
Yeah, that's a good question. So we got to unpack this a little bit because there is the AI revolution taking place right now. And that AI revolution is primarily generative AI. So when we talk about manufacturing, we will talk about the role of generative AI in all of this. But most people, when they think about AI applications, AI use cases in manufacturing, they're not talking about generative AI. They are more focused on machine learning that's been out there for a while. If you look at different surveys, at different studies, and try to see what are the executives looking for most of the time when they're trying to get benefits from AI in manufacturing, one of the hot topics is predictive maintenance, and then improvements in quality control, reduction of downtime. So those are things that depend on analyzing data over time and finding improvement opportunities, seizing those improvement opportunities, and making sure that it trickles down to the bottom line. So that's what a lot of people think when they talk about AI in manufacturing. It's not necessarily generative AI.
Eugene, what is your favorite feature of any AI application out there, whether it be in your personal life, in your kids' robots, in the kitchen, anywhere else? So what's your favorite thing that you're playing with when it comes to AI these days?
There are many different applications that are somehow augmented by AI these days, and many are useful in that way. It's hard to name a favorite, but if I say a favorite feature across the board, doesn't matter which application it is, the favorite feature would be the speed with which I can access certain information within the context of what I'm looking for. So basically, instead of going on searches across popular search engines, I can ask AI to get me the information that is very specific to what I'm looking for. I can describe it in quite a few words and make sure that I get the information that is really tailored to what I was looking for, to what I was specifying in my prompts. That is very hard to get with the regular search engines. You get millions of results and they're all across the board. With AI, my favorite feature is that it can be much more precise in understanding what I'm looking for when I'm prompting it and delivering that information to me very quickly. So I guess that would be my favorite feature if we're just talking about across the board, all kinds of applications. Which is something we're going to circle back to because that is the same flavor of the feature that we are working on in our own systems.
Konstantin, what is your favorite thing when it comes to large language models and artificial intelligence these days?
So I have two favorite use cases. One, I agree 100% with Eugene. One of the use cases is looking for something specific. And what I like about that is I can tell the large language model to go out, search the web, find something that matches a specific criteria and give me links to where it found that. And it's much more meaningful to me, the results. So absolutely 100%. So especially when you look for expert opinion on something, some very specific data, and you say, okay, for example, find me a study that covers this topic, and then it gives you different options and you can ask further questions about it and narrow down to exactly what you're looking for. Kind of activity would take a much, much longer time just by sitting on Google and searching for it. But the second use case that I work with a lot of the time is when you give the large language model something that you created text-wise, some thoughts, some points, and you want it to be transformed a certain way, and you want it to be corrected, criticized, whatever, so that interaction I use daily, so I'm saying, here's what I'm thinking about. Now try to bring this together and tell me what else is out there that I should be researching. So things like that are very exciting, and they are tangential to what we're doing with manufacturing, but they're not necessarily like a widespread common feature that everybody is running to buy in the manufacturing world.
One of the interesting features of AI is how it hallucinates. And it's a lot of fun to look at some nonsense that it produces sometimes. That adds a lot of humor into my life.
Yeah. Now, if I were to ask the same question about manufacturing, so what is exciting for you guys in manufacturing right now? You would have probably said predictive maintenance, which you have hinted at just a couple minutes ago. So can you go a bit deeper on that? Like, why is that so exciting for everybody right now?
It's actually a good question. It's because a lot of people don't fully understand what the current AI revolution is all about. It's not about predictive maintenance, but they wanted predictive maintenance for many years. And so they still want it, they think, because now we got these companies announcing all sorts of AI related products every day or every week. We should have something on predictive maintenance as well. However, with predictive maintenance, there are some interesting facts. So when we researched the latest trends and we looked at some publications, some of them by Siemens, some other ones, there were Deloitte studies, we can see that out of the manufacturers that were surveyed in 2023, only about 3% were successful in implementing predictive maintenance. So we can literally name those companies and count them on our fingers. But when you look at the surveys where they show what's the most popular topic, what is everybody after? So there is that huge disconnect. Yes, there's a lot of executives who are trying to see how they can benefit from predictive maintenance, and most of them are failing. And there's only the 3% that are successful. Yes, there's a huge segment of executives who are thinking, oh yeah, AI is here. Let me do predictive maintenance and reduce my costs of operations. But most of them are failing.
So this begs the question, why is this initiative failing?
Yeah, so a lot of people don't understand that to actually be successful with predictive maintenance, there are important prerequisites. We talk about data maturity in the companies. And when we talk about data maturity, we are really talking about the ease of access to the data. So there's a lot of data that's necessary, and usually older companies that are less mature have siloed data. Some data is here, some data is there, and you have to have different ways to access it. Some data is on paper, some in Excel, and some data is there, but it cannot be trusted because it was captured haphazardly, and it gets into the next point, the cultural maturity. So there is the data maturity and there's a cultural maturity. And culture basically means that, do employees treat data the right way? Do they try to make themselves look a little bit better when they record stuff? Do they not care what they're recording? They just record anything? Or do they treat data as a precious commodity and they think that they want to improve the business all the time, So when you get to that mindset, that's when the culture is ready in the company for something like this. And so for preventive maintenance to be successful, you need both. You need the data maturity, you need the cultural maturity, and then the preventive maintenance is sort of that pinnacle at the top where you can actually get benefits. But if you're missing something in between, you will just never get there. And there are some examples, you can hire a vendor that will bring you some kind of machine learning tool that will watch some data points and give you recommendations about when you should stop production and fix your equipment. If what that tool is watching is low quality data, you're going to get false alarms. If what that tool is watching is just wrong data, again, you're going to get false alarms. If the model, the tool is too sensitive, you're going to get false alarms. When you have a bunch of false alarms, the engineers, the maintenance people at the factory will look at it and say, yeah, like this tool just keeps giving us false alarms all the time. So we're just going to stop reacting to it. And when they stop reacting, the next one will be the real one when something breaks, but they didn't pay attention. So it's a very sensitive topic. Like, how do you think with predictive maintenance, how do any of these mechanisms work? Well, they watch what's happening. Some companies literally install vibration sensors, and the vibration sensors look at the machinery. And if they sense that the machine is vibrating more than usual, then they make a guess as to when to tell you to stop and call the mechanic to try to fix something. You will get those false alarms, and you will get people not paying attention to when the real ones come, when the problem actually happened. So that's where it's very challenging. But then there are companies that look at not vibrations, but just in general their assembly line and try to detect any kind of defects happening, and then they count them and see if today the count is too high and yesterday it was also higher than normal, then maybe something bad is already happening on the assembly line. You don't know for sure, but you might as well flag this to somebody. And then the question is, what do the people do with that once it's flagged? Do they make the call to stop everything? And every time you stop the production, it costs money. You're losing money when it stops. So do you make the call to stop it and go try to identify an issue that you're not even sure that it's there? Or do you make the call to just keep going until it shows you more problems? So that's where the challenge is. And unless you have good data and people with the right mindset and with the right attitude, so that culture in the company is right for this, then you're just not going to get the benefits of predictive maintenance. So it is a topic that a lot of people look for, but it is one of the ones that is actually very difficult to benefit from.
Sounds like not only is it required to have the right culture and adequate data, you also need the what if scenarios. Predictive maintenance is probably insufficient in getting to what we want, which is more reliable production, more uptime, less waste, whatever. But you actually need those scenarios. So, okay, what happens if an alarm goes off? I know my data is good, so I can probably trust it. But then what? And you probably need to figure out that before installing a solution.
Absolutely.
I get it. It's super important that companies need to have a relatively high degree of data maturity and the right culture with it. But if not, then how can they truly embark on a digital transformation journey?
Yeah, so digital transformation is a whole separate topic. This is where companies that are still in the industry 3.0 mindset, where they have disparate systems and point-to-point communications between them, this is where they benefit from transitioning into the industry 4.0 space, where now they have data that's easily accessible. They don't have to focus on these individual interfaces, and the data actually drives their decision making. So digital transformation, that is a strategy and not a project. This is also something that can take some time for companies to transform, to get into this space where they have things like maybe unified namespace. It would be one place where they have a single version of the truth of what's going on at the factory right now. And it's not those multiple different systems. It's like a single place where you can go to and find out everything you need about what's happening right now. So then when you integrate new tools into that ecosystem, there is just that one thing that they need to integrate with, and everything starts working together in tandem. So companies are advised to assess how they're doing things, maybe go through digital transformation maturity assessment, and then take the steps starting with pilot project where they can see the value of transforming more quickly and avoid these enormous multi-year initiatives, but go with smaller pilot projects first so that they can see how things can be very different. They can invest into IIoT devices, those sensors that we talked about, read data from the edge devices, and rely less on human input, because humans, one day they enter normal numbers, another day they might enter extra zeros. Humans are humans, so they're horrible with data entry. And so we recommend companies to actually assess what they got, come up with their digital strategy, treat data as their precious commodity, and go towards data-driven decision making. And so all of that will prepare them to reap benefit from predictive maintenance. So once they go through that, now they actually get the necessary infrastructure in place. But also with that transformation, it's not just technology, it's also the mindset of the people.
So, Eugene, where is AI making a big impact in manufacturing?
Well, there are other types of AI. Predictive maintenance is mostly a machine learning type of AI that allows you to analyze data from all kinds of edge devices, sensors, and to come up with predictions that help you in your day-to-day manufacturing. Besides machine learning, there's this big boom or revolution in AI that's happening in the generative AI space. That's what Konstantin was referring to earlier. Currently, the biggest hype and the biggest jump in AI capabilities has been in generative AI with large language models that is more of a conversational approach to AI. So instead of getting millions of data points, it gets conversational prompts and then reacts to them with artificial intelligent algorithms. Now, that type of AI is very interesting to look at also from the manufacturing perspective, since it provides different slice of the potential for improvement. So when we're talking about generative AI, what potential features or improvements or additions to the manufacturing can it bring? Well, one thing it can do, for example, is improve your interaction with the historical data. So there is a type of application that is normally used at the plants called data historians, right? Data historians are solutions that collect the data and historize it, basically record it in a time series sort of way, databases or whatnot, that can be later analyzed to develop understanding of trends, how things are working over time. Uh, Now, all of that is accessible before AI, right? We had data historians for a long time. However, with this generative AI, now it's possible to converse with an AI assistant or co-pilot, if you want to call it that, and ask questions and create prompts in plain conversational language that would then allow you to look at the data from the historian and give you the summaries and trends analysis in a much more approachable, easy way instead of trying to create charts and diagrams and reports that usually takes some knowledge as to how to do that. It's just a matter of asking, basically, in plain language. So that is one thing that can definitely be a helpful hand as far as AI goes. We can also talk about a QC, for example, right? The quality control. Let's assume that you have some product running on a conveyor or maybe inside of some processing equipment, and you get a sample and you say, okay, well, here are the results. I analyzed it. I have the results of the analysis. Does it mean anything to me as a technician in the lab? It may or may not. But if you have an AI assistant running in parallel to what you're doing, it can look at the results that you've just entered and say, well, based on this and my knowledge of the process, you may need to make certain adjustments to what you're doing right now to ensure that the product quality at the end will be up to your standards. So it can analyze the results that you've provided from sample testing and generate a suggestion, such as what adjustments potentially are necessary for the process that you're running. So that could be very valuable. Another way to think about potential improvements in how AI can help you is dashboards, for example, right? So if you want to say, well, generate me this type of chart based on that data. In many cases, it can be made a part of the application, part of the system that you're using, that AI assistant would be able to actually deliver that. Now, we may not be necessarily talking about super complicated dashboards. It really depends on what data is available for AI that AI knows about. But whenever AI has the knowledge, has the context of what it's being asked, it can do pretty interesting things with generating dashboards or reports for users that normally would take somebody knowledgeable in how to create dashboards, what data to pull where, and how AI can do a lot of that without having to go through some people with specific knowledge. So that would be another great thing that AI could do.
One thing in AI is, it's a whole separate topic, is computer vision. And so in manufacturing, computer vision can be used to detect any defects visually. So when we're talking about companies that make fruit juices or vegetable juices, you can actually use AI for visual inspection of the batch to see if there are defects, size, color, any surface anomalies. You can even use the visual inspection of ripeness. You can have packaging inspection to see if there's anything problematic with the labels or with the seals on the package. In beverage manufacturing, you can use computer vision for fill level inspection and see if it's filled all the way where it's supposed to be, or if there's something missing. Cap and closure inspection, all sorts of stuff. And then with dairy production, you can also have visual inspection of cheese and yogurt quality. And for example, if AI notices that there's some discoloration, maybe there's some mold starting to grow, like things like that. So computer vision is part of the conversation.
Okay, so in addition to quality control, what are some other areas where you're seeing AI making an impact today?
Yeah, so in supply chain management, we've got the machine learning type of AI where AI is predicting demand and managing inventory levels. So when you know your demand better, you obviously can manage your inventory better, and you then avoid the bottlenecks in the supply chain. And that ultimately reduces your cost. We also see some of it in health and safety space and environmental protection. So think about monitoring working conditions in real time and checking levels of gases to see if like the working conditions are safe. And if there are any anomalies detected, then the supervisors are alerted. Additionally, the computer vision part can actually analyze what's happening on the shop floor and identify any anomalies or any strange or disruptive behavior as well. It's tools like that that bring the sort of low-hanging fruit type of solution to the manufacturing floor. Although I would say that those kinds of tools are not widespread yet. So there's a lot of companies that are just catching up. So there are some industries where there is greater maturity and some industries where there's less maturity. We can't say that everybody across all industries plays with that, so that's the unfortunate reality. There's some companies that lead this and others follow.
See, there's a example for safety right. So if you have cameras watching the shop floor, maybe it's a night shift, not a lot of people on the floor. Somebody is walking across the floor and slips and falls, maybe knocks themselves out, and they need help. Regular camera, it will record the whole thing that happened, right? But it's not going to do anything. Now, with computer vision, with AI assisted computer vision, it can see that it happened, analyze the fact that it was a human that fell, and alert certain other individuals that might be around to the fact that somebody needs help and there's a potential medical emergency going on that needs to be addressed. So with just cameras, you will have a video recording of things happening, but with AI assisting the camera, you may actually get the help much sooner.
Okay, so all these applications, they are a reality today. So all the QC, the supply chain, the computer vision, like this is implemented and is being piloted and deployed at the largest manufacturing plants in the world. But where do you see all this going in like 5 to 7 years? So the forefront of the application, what are we going to have 5 to 7 years down the line?
I think we need to talk about both arms of AI, the machine learning and the hot topic of predictive maintenance, and then the generative AI somewhat separately. We do expect that there will be more companies successful with predictive maintenance in the next 5 to 7 years because there are companies already going through digital transformation and building that base of data maturity and cultural maturity that they need to reap the benefits of predictive maintenance. But we also expect that in the next 5 to 7 years, generative AI would be much more widespread in terms of assisting people on the shop floor, management, mid-level management, in doing their daily routines. So it may even be that the generative AI, based on how fast it's been spreading up till now, it will be more widespread 5 to 7 years down the road than the machine learning type of stuff with predictive maintenance. But there's nothing wrong with it. There will be these new use cases and there will be enhanced productivity.
Got it. So Eugene, when you're talking to plant managers and IT leaders, and they bring up the topic of AI, and they probably ask you, "Hey, where's the ball going? What advice do you have?" What do you tell them?
Well, as we already outlined, we need to think about vision first, right? So if you are thinking about bringing AI in any form into your manufacturing, first you need to have a vision. You need to set some goals. What are you trying to achieve, right? So you need to really have a good understanding of your goals with AI. Once you have them, you may want to set up some sort of a roadmap, some sort of a plan as to how do we achieve some of these goals or all of them. Because sometimes you may have some goals, but they are not easily achievable and you can't see a clear path to achieve that yet. That's okay. You can put those goals further back out and maybe focus on the ones that are showing more easily achievable to you. Once you have that, focus on potentially smaller, somewhat pilot projects on something that you can get to setting up quickly and potentially accomplish quickly to see if the value that it gives back to you is something that you really were expecting. If it doesn't match what you were setting out for, what you thought it would be, maybe you need to readjust. Maybe you need to change your parameters and shift around your goals and maybe make changes to your roadmap. So you have to be nimble to be able to reap the most benefits out of it. Once you do that, you can focus on areas such as production assistant, for example, right? You can say, I want AI in my production to be able to assist me in some way. Now, what way that is will be different from site to site, from plant to plant, but you need to focus on like a narrow specific points to make sure that you have better success in achieving those goals. You can focus on quality control. You can focus on inventory management. And it can be, again, different types of AI. Like we said, it could be machine learning. It could be generative AI, depending on what your potential, what your goals are, what you're trying to achieve, right? If it's predictive maintenance, it's a hard to achieve point. If you start small, if you make smaller steps and you get the culture going of making sure that you understand that it's a journey and it's not just, okay, let's just do it and have it done. It's going to be a step-by-step continuous improvement, working on different areas of your manufacturing, and you'll may be able to get it to your point. So those are important things to have in mind. Step by step, having a good set of goals, having a good roadmap, focusing on a smaller area rather than the whole big bang across the whole manufacturing plant that you have. You will have better results if you do it that way.
Konstantin, do any use cases come to mind, like real cases that show that this thing is working right now that will inspire us?
Yes. So in terms of predictive maintenance, we know of some examples based on public information. So we were not personally at those companies witnessing that, but a few famous ones in the food and beverage industry include Coca-Cola, Nestle, and Heineken. And Coca-Cola, they work with a lot of Siemens technology and they do monitor the assembly line and try to see in their bottling space when something goes wrong. Basically, when we try to compare the benefits that they're reaping from predictive maintenance across these companies, in a lot of cases, it's similar types of benefits. So yes, everybody talks about improved equipment efficiency and reduced downtime. because maybe if you fix something early, it takes less time to fix it than when you let it break down completely, right? But they also all talk about energy savings from predictive maintenance. And in some cases, like Heineken, they're also talking about water consumption savings. So it's reduction of raw material consumption and a reduction on energy spent due to early detection of problems and addressing them. So those are your three big, very successful companies that are good in predictive maintenance space in the bulk liquid manufacturing. And we also have examples that are not in predictive maintenance space where we personally are working with that technology. And so when we talk about shop floor AI assistant and virtual mentoring, this is more than just some run of the mill AI assistant or copilot that has been pre-trained on something. This is all of that plus the AI. So we're talking about large language model now. The chat bot or voice input bot, doesn't matter, that actually, in addition to knowing whatever you're involved with, your standard operating procedures, your user manuals, it also monitors the state of execution and manufacturing constantly. The value of what it can tell you, what its advice is many times greater than with just any normal chatbot. And it's funny, I'm saying normal chatbot, given the AI revolution and given that a lot of companies have already created them. But when you talk about full context awareness in real time, we are talking about, okay, imagine I'm an operator and I have a machine running and making something. So full context awareness for my AI assistant means that that AI assistant knows every second, every millisecond, whatever it may be, what exactly is happening right now, what I'm working on. So it's watching your execution. And if I ask it, what do I do next right now? And then I ask it, what do I do next 2 minutes from now? The answer will be different depending on what stage of execution I'm at. That's where the real value is.
Yeah, just to be clear, Konstantin, so this is embedded into Eukodyne's manufacturing execution system called MFX, right? So we're talking about that live feature.
Yes. So we are able to collect feedback from shop floor operators, and they're very excited about this because you can help them by putting information such as troubleshooting at their fingertips. But at the same time, as you monitor how they're executing production, you can say, oh, now you actually need to do this. And now you need to do that. So that's where it's true collaboration. It's true value. It's not something that just doesn't know what you're doing. It's like helping you in real time. And with
It's almost just having a coworker.
yes, yes.
It's like you're doing things and you have a coworker that is very vigilant, that's watching what the process is, the process that's happening, and at any minute can help you answer a question if you have one. It's very, very exciting.
This is pretty rare. I'm talking to the listeners right now, ladies and gentlemen. What we're hearing now is that AI applications in manufacturing execution systems are totally not common in 2024. Totally not common. And what Eugene and Konstantin have direct experience with is developing a useful application that increases efficiency but reduces errors and putting that into people's hands on the shop floor. I wanted to know what's people's reaction to that. So the first time they get their hands on it, I'm guessing that you might have been on site when you were piloting this solution. What was people's reaction to it?
There's a lot of excitement and people just say, okay, when can I start using this? The thing to understand here is, yes, some of what we're able to tell them comes from their own plant documentation. But if you think about where that documentation normally is and what it looks like, you have these binders that people need to flip through. Basically, when people are executing in real time, most of the time, they don't have the time to go back to those binders and look something up. That would require a lot of persistence and strong motivation. But in cases that we explored with them, they basically need to know right then and there, what do I do now? I have this issue. And so with the help of AI, we're able to extract just the right information and not give them volumes of stuff to read, but give them just what they need right now, and it's instant. So they're very, very excited about it. And it looks like this technology is not going to dumb down the workforce, but actually help train them on the job to make them better at what they do.
And it doesn't have to go for any kind of breaks, right? Humans have to go for a break. It could be a bio break. It could be a meal break. It could be any kind of break. Having a coworker inside the machine that never takes a break, that always watching what's going on with the process that you're running, and it's not going to miss anything, basically, right? So you look away from the screen, you might miss something. This coworker of yours, it's not going to miss anything, and then in case you did, it will let you know.
That's awesome.
Yes. And we have some other examples of the stuff that we're working on where, again, this new technology shines in all its greatness. So when customers of our clients provide feedback to them, it's usually free-form text that is sent in an email, and then somebody sits down with a dedicated software module where they capture all that stuff, and they have to categorize what kind of feedback they received. And when you get to the level of like organizations with high volume of feedback happening, then it's no longer just one person looking at this. There are multiple people, and it becomes a little harder to make sure that that categorization of everything is correct and thorough. And so what we've seen is that in some cases, when certain maybe departments, certain sites realize that, hey, I'm receiving a lot of feedback from my clients, and some of it may not make me look so good. So wherever it's borderline or questionable, maybe I'll categorize it in such a way that that category doesn't penalize me at the end of the month when my metrics are calculated. So people are very clever with doing things like that. So then what happens is somebody will do random audits of these records, somebody else usually, and say, oh, wait a second. So the feedback from the customer actually indicates that this is our problem. And the way we addressed it was we solved the problem, but then we categorized it in a way that kind of looks like it wasn't our problem. And so that didn't impact us negatively. And so now the exciting thing is that with large language models, we're actually able to make sense of all the commentary that's captured in the system, and then ask the question, is this categorized appropriately? How should it be categorized? And then we are putting that in so that people are assisted in real time as they're capturing stuff. People can always override that. And so then you can give an on-demand function to that auditor to say, hey, how about we scan everything here at this site or for this department right now and see where there are anomalies. And so AI is now able to go through a lot of text, find what the customer said about you, what AI thinks based on the rules this should be categorized as, and then tell you, hey, yeah, somebody might have cheated a little bit here and given themselves a higher grade. So this is very exciting because up till now, we weren't able to take those huge volumes of text, they just free-form text data that's captured in different places in manufacturing, all sorts of notes, all sorts of commentaries, and try to make sense of that and see if any of that actually contradicts what the normalized data, the structured data says. So that's one of the things we're involved with. And then there's another one with the invoice reviews. Now, invoices and accounting departments, this is not just in manufacturing, but in manufacturing, we've encountered this particular phenomenon when you have suppliers that give you something at high volume, something very frequent. Very often, companies in manufacturing space don't have the dedicated staff to check every invoice for accuracy. And even if they did check, some things on those invoices are hard to verify quickly just by looking at it. So what you need is you need the ability to compare what's written in the line items of the invoice to some other data source to see if what they're billing for is actually legitimate. And so now we've learned that AI got very good with computer vision technology at looking at invoices and extracting data out of that. And then if you line that up with the additional data feed that actually tell you, oh, if they're billing you for shipping containers, for the cargo that you ordered, for your raw materials for production, and your supplier is sending you a lot of invoices every month, you can actually line that up, extract it all out of those invoices, line that up with shipping container tracking data, and see where you are being charged for the days that the container wasn't there. And you'll be amazed that happens. That people get charged for things, and if nobody is looking, they just pay them. But now this technology can actually help you look at that and flag the anomalies and say, hey, there's something going on here. So we were talking about virtual mentoring, feedback management, and invoice review.
Yeah, it may not be necessarily malicious intent in providing invoices with charges that shouldn't be there. It's just because people are doing it, right? And people do make mistakes, especially when something is of high volume and high repetition. It's easy to make mistakes that way. When something happens rarely and you focused on it, more likely than not, you will not make mistakes. But when something happens very often and the things that are happening are very similar to each other every time, then you can make mistakes easily. This is not to say that they're malicious intent. It's just to say that AI may be very helpful in finding those mistakes and preventing, the outcome that's like paying extra.
I love these examples in the end. So I loved how you guys got super practical. And I'm sure this is going to be a great resource for plant managers and IT leaders at manufacturing companies. And I want to thank you all. Any closing thoughts or remarks on this topic? Of course, we could be talking for weeks and months about this, but just for this one episode, is there anything else you wanted to mention?
I was going to say AI is not just a buzzword. We've covered in this episode the differences between traditional machine learning type of AI with the predictive maintenance example. And we do believe that companies will get better at this in the near future, and there will be more companies that can actually reap the benefits of predictive maintenance. And then we talked about generative AI, and I strongly believe that that will be more widespread and the individual people at the factories will become more productive.
So if you think about predictive maintenance, machine learning, those things are usually take place somewhere in the background. Nobody knows about them. Let's say it's successful implementation, right? And the company is actually reaping benefits from it. It's still somewhat like disconnected. When we're talking about generative AI, that is very personal because it's actually everybody who's touching the particular application is actually conversing with that AI copilot, right? So it's a much more intimate relationship between the actual workers and the AI technology because it really is just there at their fingertips or their voice, right? So they can just ask. And that's one of the things we're working on as well, that voice input, instead of typing something, you can just ask something and it does pretty much the same thing as typing it, but much faster.
Right. Well, gentlemen, thank you so much for being around today. That was episode 10 of the Efficiency Equation podcast. And congratulations again for the two of you for having made it to double digits. And we will see you in a couple of weeks. Until then, take care. Bye-bye.
Thank you. Bye.
Thank you.